So the idea is that we were intrigued by these differences between United States and European breakpoints, as published by CLSI on the one hand and UCAST on the other. So on this plot, the R breakpoints are red and the S breakpoints are in blue, and you can see the scatter plot from the paper where American breakpoints have been plotted against European ones. And the scatter plot, the correlation isn't high. It's about, half, a bit above a half, which means that for particular drug-bug pairs, the breakpoint difference can be orders of magnitude apart in terms of dosage measures. So when you look at drug classes, you separate this kind of picture out into drug classes, you get a plot like this, whereby most breakpoints bias towards the US, but not all. Some bias towards UCAST, like daptomycin on the one hand. So when colleagues like Branka in Belgrade, who works in Serbia, when their country has swapped from CLSI guidelines to UCAST, this has meant that patient treatments have changed, dosages have changed. So the breakpoints are different, but are the MICs underpinning those breakpoints also different? We need things like Atlas for this. UCAST data is not enough. So when you look at the panoply of drug-bug pairs, you get a patchwork of correlations as here. Sometimes you get high correlations, sometimes you get low correlations between regions or between organizations, which isn't a surprise perhaps. So what we wanted to do was try and dissect this. So we took that data set from Atlas. We could then apply optimal nearest neighbor classifiers to it. So we could do things like, if you give me a string of MIC data from a patient, which is what Atlas does, that string's incomplete. What we can do is decipher its origins using this classifier. We can decipher its species and we can decipher its continent. But then, we get that decision wrong about 25% of the time. But what it's saying is that there's a lot of richness within our MIC data. So when you go back to the comment of Cusack et al. About harmonization, that could well be true, but also do we need to think about species-specific breakpoints on all continents? Now that, if true, would mean a really heavy workload. It's almost impracticable, but maybe neural networks can help with that. So we trained several thousand neural networks, artificial neural networks, on UCAST MICs and their breakpoints, and we retained 100. So we have a neural network ensemble that can predict breakpoints and breakpoint decisions. There's a beautiful correlation between the American neural networks and the European neural networks, something we don't see in the real world data.